Hi, I'm Alona Tursar. I will present the skeletal part and their function. Skull, bony cage of the brain of fish. Orbit, cavity contains the eye. Upper jaw, upper part of the mouth. Lower jaw, mandible, lower part of the mouth. Clavicle, shoulder bones. Pelvic girdle, set up bones forming the pelvis. Pectoral fin ray, bone forming the chest fin. Pelvic fin ray is the bone forming the fins of pelvidel. Ribs is the bones performing the thoracic. Radial cartilage, elastic substance of the radius. Anal fin ray is the small bones forming the fin. Hermal spine. Caudal fin ray is the small bones forming the tail of the fish. Hyphural bone are finny rays of the caudal fin of a fish. Vertebra, bones forming the neural spine of a fish. Neural spine, containing part of the nervous system. Ray of posterior dorsal fin is the small bones forming the reed spines of the back of the fish. Radial cartilage, elastic substance of the radius. Ray of the anterior dorsal fin is a small bones performing the front of the back of the fish. Operculum, fleets covering the gills opening. Swimming behavior. Swimming behavior is commonly used by fish. It consists the cyclic course of swimming movement followed by a cause space in which the body is kept motionless and straight. Yellowtail scald. They swim past in mid-water in pursuit of zooplankton. Yellowtail scud or salay-salay uses its body for locomotion. The tail function is a motors and the remaining fins are used for stray range and balance. Insight as to how a fish swim has been obtained from studies with machines. Most machines apply power by means of wheels or shaft rotating about a mixed axis, usually at the constant speed. In animals, this arrangement is impossible, since all parts of the body must be connected by blood vessels and nerves. When fish use their trunks to move through the water, they use the backbone as a lever. Muscles are the power sources which pull and push the lever by contraction. Each vertebra is high to the next vertebra in such a way that movement is possible only in the single plane. A fish moves forward by sweeping its tail sideways. The force of the tails against the resistance of the water produces a resultant force that propels the fish forward. As the tail sweeps the directions, the front end of the body, since it is on the opposite sides of the hide, must tend to swing in the opposite direction. Controlled study of swimming speed have clearly demonstrated that the speed of some fish are much slower than most people believe. When a stationary herring, alewife, or bass is started in, it appears to move off an extremely high speed. Form and function. They form large demersal schools over soft bottoms habitat and depth shallower than 50 m. Around midnight, The vertical swimming direction changes from predominantly downward to upward. Several hours before dawn, the fish start ascending toward the surface in the stepwise pattern. After ascending to upper layers at dusk, leave the surface water not by sinking by the actively swimming in the stepwise pattern characterized by relocutions alternated by pauses. Identification. The species is recognized by its silvery colors stained with green or brown dorsally and yellow tail. It has a distinct dark spot on the rear margin of the operculum. It has enlarged scales called scutes along the entire lateral line. The pectoral fins is sickle-shaped or falcate. The caudal peduncle is very shallow and the tail is strongly forked. It lives in a range of habitats from the surface of 500 meters. Distribution. The yellow-tailed skald is common schooling species of Australia, southern marine water from Whitby, Queensland to Northwest Cape, Western Australia. That's all. Thank you.